So focus of this talk is going to be on React components and what causes them to render and how lots of renders can make your app slow. We'll go over a few tools that you can use to identify some hot paths in your code, especially in the faithhive.com project. These are tools that have been out for less than a week, so I don't know them really, really well, but I've gone through some of the basics and I'll walk you through what I've learned so far. Okay, if you've used React for any amount of time, I'm going to close my mail app so this stops popping up. One moment, let me close some distractions. Why did they even pop up? I don't know how to turn on Do Not Disturb on a Mac. Am I in the right area? Do Not Disturb, there it is. Okay, I'll do the same on Windows. Focus Assist, that's right, that's what they call it. Okay, in a typical React app, you have a component, which has other components, which has other components. And any number of these components can contain state. So by default, whenever state updates in a top level component, like let's say the newsfeed here or this list of items, will cause every item to be re-rendered or to have the render call invoked, even if calling the render function would result in exactly the same DOM nodes being created, render gets called no matter what. In most cases, this is fine. Most components don't have thousands of elements that they're rendering, but in this very contrived example, that's exactly what we've done. So at the very top here, is that font size okay for people in the back? Patrick, can you see? I'm in app.js. This is really the only file in this project that we'll be caring about. In this very contrived example, I have this generate items functions, which creates an object with 3 props on it, A, B, and C, and a unique ID here. It's making 1,000 of them, but if you want to see how bad it gets, you can up it to 10,000 or 100,000. And then in our state here, I have a few different modes that we're going to try out so we can see how fast they render. I've also created a very, very simple timing function. So right before an update happens, we get the date. And then when component did update happens, we just measure the difference in milliseconds. And then we mutate the inner text of a node, which you would never do in a production app. But for the sake of this demo, it's the simplest thing that we can do. And then the render is pretty simple. If you scroll down to the bottom, we have just a map that goes over each item and renders a row. And each row has 3 almost identical declarations of render item. And render item is either, whoops, I gave away some of my later demo. This doesn't look exactly like your machine. Render item looks either like this pure item, which extends pure component, or a functional component here, which looks like this. Quick overview of functional components and class components. They are mostly the same, except functional components don't have state and they don't have lifecycle hooks. So things like component did update, that sort of thing, you won't get those with functional components. This talk is intentionally not focused on why you would want a functional component over a class component. That's saved for another time. We're just going to talk about the performance benefits here. With a functional component, though, you can invoke it just like you would a regular function. So up here, instead of calling this.renderItem, you could say this.renderItem and invoke it with the props that you would want. You can't do this with a class component here. Whereas this syntax works for either a class component or a functional component. We'll go into some of the performance benefits of doing this later. This is also meant to be a somewhat interactive talk, so if something I said is unclear or you'd like me to go over it again, just let me know and we'll do that. So that's a basic structure of this app. It's intentionally simple, just go over 1,000 rows and render them. So every time I click on this React symbol, it causes, it just runs a set state with nothing in it. Let me show it to you just so yeah, there we go. So we're just calling this .set state. We're setting nothing, but it could be like foo is 1 or whatever. But the important bit is all of these components are getting re-rendered here. And we know that because in the React DevTools, there is a mode that you can enable, which will flash any component that is rendering on the page. So what I did is I went to React here, under their elements, there's gear, click that and click on highlight updates. And then anytime you do an update, you'll get this nice flash of blue for everything that's getting an update. It's like my remote desktop is being a little laggy, but you can see it sometimes. So that functionality has been there for a while, but there's this new Profiler tab, which will only appear if you've updated to a later React version and you have the new React DevTools installed. So the way this one works is when you click on Profiler and hit record, it will capture all of the state updates that happen in your application and then allow you to step through them and see what caused the state update to change and what components got rendered as a result. So if I hit stop here, I just did 5. I just clicked on the React icon 5 times, and we now have 5 state updates here. Does anybody not see this tab, the Profiler tab, on your workstation? No?
I don't.
You don't? Okay, if you don't see it and you're on Chrome, the extension might not have updated yet. So as long as you're running the sample app, that tab should be visible.
It's perhaps worth noting that turning on highlight updates could affect your profiling.
That is true. Thanks for bringing that up. Having the DevTools open at all will affect the performance of your app because it calls into some secret hooks into the React code itself in order to figure out what updated. There's also this performance tab, which you can enable, and the React docs have some great articles on like how to properly use the performance tab. And you can also use this cool CPU selector here to simulate really slow devices. So you can say like, what does a 4x slowdown of performance look like? So I'm gonna click this, and it's taking over 3 seconds to respond, which is terrible, but we'll go over how to make that better. 6.5 seconds, awesome. Okay, so now that we've gone over the tools that we'll be covering here, it's important to note that there's a distinction between writing sloppy code that's obviously bad and writing code that's clean but not necessarily like unnecessarily optimized. Whenever we introduce some complex code to work around or to get some hypothetical speed improvements, it's always important to measure the costs of this code that we're adding. So Pure Component is an example of this because there's some things that you have to be aware of when you're using Pure Component. So this talk is also not trying to emphasize write the sloppiest code that you can, but rather measure the effects of the code that you're writing and evaluate what's the cleanest way to strike a trade-off between the code that's really easy to understand or clear to understand in code review and also not burning CPU when we can avoid it. Okay, so what can cause a re-render of a component? Basically, anytime if you are just extending component or using a functional component, render will be called anytime a parent component renders. So if you have your parent app.js and state updates in it, like we saw here, every component in the list rendered. So there's a couple of escape hatches you can use to avoid this. Should component update is a pretty common one, and Pure Components leverages this pretty heavily. So with Pure Components, and you can read up on this in the docs, I'll post links afterwards, but with Pure Components, a render call will be skipped only if all of the props are shallowly equal. So if you have a string prop A and a string prop B, and both of them are equal to the previous props, then render won't be called on the component at all. This is handy in a list like this because all we're doing when we're clicking this logo up here, oh, my tab appears to have crashed. I will try that again. When we click on this logo up here, this is just without optimizations, we're hitting about 370 to 400 ms. If we turn on Pure Components and click on this, we're hitting slightly less, better. And if we look at the React tab and flash our updates, and this might not be the best demo over remote desktop, so bear with me. We'll be able to see, why didn't that work? It turns out the React tools also are not very performant if you're rendering a list of 1,000 items. I must have some other app that's slowing down my machine because this is taking longer than it's supposed to. There we go. So that's with every, so should component update is being called on each of these. It looks like blue also flashes if you're.
So I noticed the unknown is rendering. That's what the blue is rendering right now.
Yeah, and so that's our pure component here. So the path that it's hitting, unless I've got a bug locally, is this guy here. So we're doing extends pure component and we're evaluating this here. I might need to have a nested component to really show the trade-off here.
So the this.render item is is the blue that's being rendered when you're.
Oh, thank you. Yes. Yeah, that makes sense. Okay, and so if we look at the profiling tab, because this app, like this, these are just divs that are getting rendered. These aren't child components. The profiler isn't going to show us a lot of interesting information. It's just going to show that app itself had several state updates. But with each of these, we can see that the state here in items, like if you called add item, then some items would grow each time we click that, and then it would show that we have this item pure that's being called. So with just this example, there's a gotcha you can run into when working with pure components. When dealing with string props or really simple types, the shallow comparison will pass. So like, let's say you just have a name prop, which is a string. Shallow equal of string works if you're comparing one string to another. But if you're creating a new object or a new array each time, or even an arrow function, the shallow comparison will fail. And so in these cases, and this is relevant to some topics that have come up recently, if you're using an arrow function in your render, which is, oh, here it is. This is an example of an inline function declared. This will always fail the pure component check. So by making render item a pure component, if we're using an arrow function here, we've actually made our performance worse, because instead of just calling render each time, you're calling should component update each time, and that goes through and does a comparison of all the props. That always fails because this creates a new instance of a function, and then we go ahead and call render. And this is why it's really important to measure your performance here. You can't just make a rule that says pure component everywhere, because in many cases, you may have actually made your performance worse instead of it being better. Questions about those so far, arrow functions or how they work? No? Okay. So we should be able to measure this here if my workstation is, there you go, it's a little bit happier now. So here we're using, this is just a regular functional component with, without bound functions. So that's what this toggle bind false does, is it alternates between using pre-bound functions and creating arrow functions. So with each of these renders, it's somewhere about 500 ms. There's a few outliers. With bound functions true, it's about the same, maybe a little bit worse. And then we have if we have pure components on and bound functions, we consistently get above 500, sometimes 600 ms. So if you're considering using pure component in your app, you have to be sure that you're in the majority case, your shallow comparison is not going to fail. There's a few experimental approaches you can take later to avoid, or we'll cover this a little bit later, to avoid re-renders, even when using arrow functions. There's some Babel plugins that we can adopt to make this better. But here I've disabled bound functions and turned on pure functions here. And now my render is about 350 ms for rendering the whole thing. So Here, we're trying to optimize for maybe 100 ms, or we've seen a trade-off between 100 ms, 200 ms for rendering 1,000 items. But in most of our apps, we really aren't rendering that many components. So even a list of 100 items at once, it can be pretty excessive. So here, it's like 50 ms, and with bound functions, still the same, pure component without bound. Okay, so we shaved 10 ms. Whereas most of our latency in an application is not from should a component render or not, but in API calls or bloated CSS that's rendering or that's coming down on the page, or maybe some polyfills that are taking a while to load. So before deciding whether or not pure component is the right thing to do, you have to measure if this is really where we should be focusing our mental energy, and if using pure component is the right thing to do. Now, I added this button here, Enable Cheats. If you have the app cloned, you've probably already seen what this does. But there is a separate strategy that has nothing to do with pure components or should component render or should component update. And so I've gone back to my old mode of 500 ms. If I turn on my cheat mode, you can see that renders are really, really fast. And even things like adding items are really fast. And as we scroll down the page, we can see that all of our items are still here. So what the heck is going on? This is called a windowing technique. So what we're doing is, as the name implies, we are cheating. We're not actually rendering 1,000 rows. We're only rendering a handful. And as the list scrolls, we are absolutely positioning each of these rows to give the illusion that there are 1,000 items on this page, when really we're only responsible for rendering about 20 or so. There's several libraries that do this. A really popular one is called React Virtualized. And it's common to use a technique like this when you have a feed-based service. So Twitter does exactly this. If you try to use Twitter mobile on your device, you'll notice that there's a tiny delay. Like if you're scrolling fast, notice that some of it's white. It's because the rendering or the windowing hasn't caught up yet. But this is an example of like we've gained an order of magnitude better performance here by not focusing on whether this component renders or not, but should it update, but rather should we be rendering entire classes of components at all because they're rendering out of the visible window. So this is a cool one that I really want to see adopted in more of our feed-based products like faithlife.com. You'll notice as you scroll down the news feed, what's that? Yeah, sure. Like the calendar month feed would be another one. As we scroll down the news feed, we're definitely not doing this. Like as we keep going, all of the posts that were at the very top of the page still have event handlers registered for when the time changes because we have this cool timestamp thing. They still listen to, did we receive new replies on this post? All of that's still active here. So in this case, we've optimized for both performance and caught and avoided rendering entirely for stuff that's out of view by using a windowing function. And this is recommended by the React docs as well, is if you're already thinking about performance, think about just not rendering your components at all that are out of view using techniques like this. Questions about how that works? There shouldn't be anything preventing us from using this in Faithlife. It's just, I don't think anybody's really thought about that yet. So it's something that we should be adopting pretty soon. Because this was really easy to drop into this demo. There's a few components that it manages to listen to, like when the window scrolls. It doesn't have to be items on the window or items that scroll on the window. You can have like a box that has inner scroll in it. It works for there too. But here I have this list components that has a render function for how the rows get rendered. Okay, so I called this out in my notes as the wrong dragon to slay. I would hate for us to get lost on doing micro optimizations when the real performance loss in this case was rendering a ton of items that were out of the visible window. Okay, so now let's focus on faithlife.com a bit because I want to play a quick game with you all. This game is called how many times is render called? So here, I'm going to go to the React tab and start profiling. And this tab will not be visible on your local build of Faithlife because we haven't updated to 16.5. I just did on my local machine, and we should be able to, but anyhow. So we can only play this game on this machine. All right, so I'm gonna click in here and type in some text, and then hit post. Okay, so before I hit the stop, well, I'm gonna hit the stop button and then tab away so you can't tell. All right, so how many people think it was between 1 and 5 renders to do that whole sequence of events? Nobody. Okay, how about, How about between 5, how about 5 and 20? Between 5 and 20 renders. Nobody? One person. Okay, 2 people. How about between 20 and 40 renders? Okay, how about between 40 and 100? Okay, closer. How about more than 100? Okay, so we're really all across the board. Okay, what actually happened here was 55 renders. So, and this was between basically every keystroke here caused an additional render to be called because we've got this post button that needs to know whether there's text in there or not, which is inefficient. It could just go, is there text or isn't there? And then only call a state change when that happens. But we can step through and see exactly why render is called for each of these. So with the first one, oh, by the way, if you type too quickly, there are frames that it will miss, and it'll call it out as like, you were typing too fast, and I don't know what caused the update. So here, there's a few different views. Yeah, here's where there's timing data missing. So this is a frame that's not helpful. So let's capture one. So here's a state change in base editor. It doesn't tell you what it was before, but it does show you all of the props and all of the state here. Here has text is false. Here's one where we had a state change all the way up in fetch router. So going back to our flame graph here, we can see over time it flashes yellow where the state changes are happening. So lots of changes here in base editor, and then when I hit the post button is when we had a callback all the way up to this fetch router parent component, and it caused a render of everything here. Now, this isn't so bad. In this case, the renders were appropriate because we were creating content in the reply feed, and we needed to know like this one count needed to change. We needed to display the replies here. So this isn't a bad example. It's just a cool visualization for what's causing your renders to happen. Here in the main newsfeed, we have a similar thing going on. Let's go to the profiler and capture it again. So I'll scroll down and we'll fetch some items, and then we'll stop profiling, and we'll see there are 15 state updates here. So here's one where we fetched more newsfeed items, and that's weird. What's going on down here? Scroll into this. The text editor is rendering. I don't know why it's rendering because it's not in view. That might be a large viewport thing. That's kind of weird.
Maybe it's because there's new reply editors technically.
Yeah, it might be the case. Yeah, so each time we page, we can see that we're calling a state update here in fetch router, and it has new items here in the newsfeed, and that's all expected. Okay, so with these tools, it would have been really hard, or without these tools, it would have been really hard to identify where our renders were coming from. That's part of why I'm so excited about these tools shipping, is without having to go to the performance tab, hit the record button, and then figure out exactly what JavaScript functions are being called, and trying to figure out state information from there, we have all of this information on the React tab. If you really want to figure out like where we're losing time in extra allocations or some chunk of time where where everything gets paused, this is still helpful. Although it is, I'll also show you timers and stuff like that. But this is less helpful than the new profiling tab. Okay. What else did I forget to talk about? Talked about the slow CPU. This is something that we should do anyway, is find out how your app performs on devices that are not, like $3,000 workstations. Most of our customers don't have those. They have like loaner PCs from 2008 that never got returned and running Windows Vista and yada yada. Yeah. So as far as recommendations, just to give a quick recap, please do not go and apply pure components everywhere unless you know that your props are relatively stable. So if you're using a render function, do not use pure components. You will make things worse. And in many cases, it really doesn't buy us anything unless we're in a feed like this where you're rendering, hundreds of this type of component, or maybe a component that has a really deep render tree, like some of the ones we saw here. We have a little bit of time left. That was about half an hour. So I'm going to go over some kind of some cool experimental things that you can try if you do want to use pure components. But before I go on, any questions about any of that?
I want to know if they're calling functional component as a function instead of as a JSX type.
Sure. Okay, so that's a great segue. I did a little bit of research on this the past couple days and found that when calling React.createElement directly on a functional component is slower. That's slower than just calling the functional component directly, but this only works for functional components. There is a cool blog post that I will link to later where somebody did a big analysis of this. But since this is a workshop, let's just try it out right now.
I would expect some amount of difference because they're doing less things. Like, I'm not asking React to call the function for calling themselves.
Mm-hmm.
I wouldn't have expected it to be major.
Well, let's give it a shot and see if it makes a big difference. So here we are in our with bind, this render item. So we need to transform this call. We'll just do it without bind. So we'll change this. We'll say this state with function call. And it goes to this. I must have a problem somewhere because all my syntax highlighting broke.
Delete that last.
Which Bren? This guy here? This one? Thank you. I'm not sure that's what I wanted though, because I want all of this to be in a block. So this way, I hate live coding. I'm not very good at it. It doesn't like that I did nothing here.
Yeah.
There we go. Okay, so let's take each of these and move them up here and format it, and then I'll add a new button next to my cheat code one. So here we go, toggle pure, toggle bind. I'll add a toggle cheat one, or toggle with function call, and then the function call. I think that's what I called the prop. Please correct me if I'm wrong. Okay. Great, so let's go back up here. We now have a with function call. This should be exactly the same. Okay. So now in our with function call, we're just going to call just item with contents is set to item.a. And on click is this dot add item. All right, does that syntax look right? I hope the answer is yes. We'll find out shortly. Okay, so we just compiled it. We're now rebuilding with function call. How much faster is this? Dang, that is really fast. That's 110 ms. Let's turn that off. Wow. That is way faster than I expected. So the blog post said something like 50% speed improvements. That looks pretty close. Yeah, so there is a, okay, so what if we did, I can't mix this and my cheat mode because I haven't modified the syntax for it yet. Adding items should also be pretty fast. So there is a Babel transform that will do this for you. But it relies on some things that are in the Babel polyfill. So let's see. I found it. Here it is. Transform React inline elements. So it takes this and it doesn't give some good examples, but anyhow, you have to add this Babel plugin, and then it will walk through your syntax tree and figure out, oh, it's a function. Okay, I can remove react.createElement and then call it like a function instead. I have not evaluated whether this works on the Faithlife code base, but this would be an advantage of using functional components. Hopefully in the future, React will do this for you, but right now it's kind of experimental. But you can, it's totally fine to use this syntax in the components that you're creating. Like this isn't bad, but just be aware that this will only work with functional components. And especially if you're rendering a list that of like 100 items, like in the calendar month view, syntax like this, or using this technique can save you time. Sure. I don't have it up right now, but I'll post that afterwards. That the root cause is this gets compiled to react.createElement. This just is a function call, and so it saves a few method calls. Okay, another experimental technique, which I almost got working before this demo, but ran out of time, is this this library called Reflective Bind. And what it does is allows you to still use arrow functions in your code. So if you have a function here, so like purechild onClick, this will get transformed. This arrow function will get pulled out into its own function declaration and won't get reallocated each time. It's basically smart caching for arrow functions. And it's supposed to be a relatively drop-in replacement, or it's supposed to be a drop-in library that enables these types of optimizations. I have not tested it yet, so I cannot vouch for it, which is why I'm labeling this as an experiment. But these are a couple things that I'm going to try so that we don't have to go back through our Faithlife code base and turn a lot of things into functional components and that sort of thing. I'm looking for optimizations that the compiler can make for us and make smart decisions about whether the performance trade-off is worth it. So this already has some smarts built in of whether this optimization will work or whether applying this optimization will work or not. Here, I'll just link to it in chat so people can read it instead of trying to read my screen. I believe this is, yes, thank you, Robert. That is exactly the article that I was after. So it's got a whole bunch of detail in how this works, but it's similar in nature to the thing that David was experimenting with a couple days ago of binding functions ahead of time, like onClick. It's the same concept, except it abstracts it away a little bit further. Who is this person on the couch? Oh, it's Ian. Thanks, Ian. Since we're on the topic of performance, I just want to call out a reminder to this cool network tab that will show you all of the requests that your app is making and tell you the weight of what you're pulling down. So for instance, in Faithlife here on my local unoptimized build, the components bundle is a whopping 8 megabytes. Now this is, I think this is post gzipped, which is helpful because whether it's gzipped or not, your JavaScript compiler still has to evaluate all of the source code and yet it doesn't come for free. Share bundle is 2.4 megabytes. A CSS bundle is going to be 1 megabyte. So pay attention to the asset sizes of what you're pulling down, along with what network requests are being made and the size of the data that's coming back. But yeah, so that these tools, the network tab and the React tools, are the ones that I use almost every day when I'm building React components. Okay, that was a lot. So I encourage you all to read the links that were posted in chat afterwards and play around with the example app. And if you are interested in doing pair programming on how do I make this component faster, I'd love to sit down with you and work on it. Any last questions?